Hi, today we are going to be working on Unit 4, Day 10 notes. We're going to be talking about symmetry. This is the last day of notes in this particular unit, and we're going to be looking at symmetry of a function from its graph and also from its equation. Okay, let's look at some examples of what this means. If you look at this particular function, f of x equals x squared, this is the parabola that we have been working with. And if I transform it by mirroring it on the y-axis, you can see that it will lay right back on top of itself. It matches up there right on top of it. Obviously, the 10 and the negative 10 are backwards because I flipped it over, but the function itself is laying right on top of where it was. So this function is symmetric about the y-axis. This piece would lay over on this piece if the y-axis was a mirror, and this piece would be on top of this piece. So it is a mirror image on the line y equals x. And when you have that situation, we have what we call an even function. Every even function is symmetric on the y-axis. So take a second and write that in your notes, that every even function is symmetric on the y-axis. All right, so here's an example that they have, and you can see that this point and this point are mirror images of one another. Now, if the x value over here is x, any x will work, it doesn't matter. The y value will be f of x. Now look what happens when we mirror it across the y-axis. The sign on x changes because we have positive values on this side and negative values on this side. So my x became negative x. But look at f of x. Do you see that f of x and f of negative x are the same? My y value did not change. So the way you can tell if a function is even from its equation is if f of x and f of negative x are the same for all the x's. So let's check this one out. This particular one is f of x equals x squared minus 4. And I'm going to test f of negative x. So I'm going to put negative x in place of x. All right, well, a negative x squared. Squared means multiply by itself. Negative x times negative times a negative is a positive. So I get x squared minus 4, which is exactly the same as what I started off with. So because f of negative x and f of x are exactly the same, then I can say this function is even. It doesn't matter if I can see the graph or not. I can determine that the function is even based on the equation that I have there. So for every even function, if I have the graph, I'm going to see if it's a mirror image on the line y equals x. Right there is where my line is, my axis. Or if I have the equation, I can check to see if f of x and f of negative x are exactly the same. All right, the other type of function we have is this. And you can see here I've got g of x equals x to the third. And we've been working with x to the third. That makes this squiggly sort of shape. Now look what happens if I take that shape and I rotate it 180 degrees, letting the origin there be like the point of rotation. Do you see that it just lays right back on top of itself? So this piece was down here and it rotated up there. This piece was up here and it rotated down here and it laid right back on top of itself. Again, the 10 and the negative 10 are opposites, but the function itself is right in the same place. So that is what we call an odd function. Every odd function is symmetric on the origin. And if you remember from what you did about symmetry in middle school quite a long time ago, point symmetry, the origin is the point 0, 0, and point symmetry is a rotation. If you can spin it 180 degrees and it goes right back on top of itself, then it's odd. Okay, so that's what happens when I have a graph. You can see the visual here where they've rotated the point right on top of itself. And look what it says here. It says for every x that I pick, no matter what it is, as long as it's in the domain of that function, and I substitute it in, I'll get exactly the opposite of what I started with. So this negative in front of f of x is basically saying that I'm going to get exactly the opposite of f of x. So let's test it out. If I take f of negative x And I'm going to put negative x in there in place of x. So I have negative x to the third. Well, that means negative x times negative x times negative x. You guys know how your exponents work. Well, I'm going to write this one out so you can see these two, negative times negative is positive. And then positive times negative, well, now I'm back to negative again. Okay, so look, I started off with positive x to the third, and now I have negative x to the third, which is exactly the opposite of what I started with. So because f of negative x, right here, is exactly the opposite of what you started with, this function is odd. So if you didn't already write it in your notes, write down that every odd function is symmetric on the origin. And then next to that, write down this part, and that means that it is the opposite of f of x. That notation is a little bit challenging. Okay, so what if I have something like this? If I look at it on the y-axis here, I can see that the left-hand side and the right-hand side are not mirror images of one another. And if I try to spin it 180 degrees on the origin, I can see that I'm not going to get the same shape with that either. So this one is neither. It's not symmetric about the y-axis, so it's not even. It's not symmetric about the origin, so it's not odd. And let's look at what happens when I substitute in negative x. So I've got negative x to the third. And then in this parentheses, I'll have negative x squared. I ran out of room there, minus 2. All right, negative x to the third. Well, we just looked at that on the last screen. Negative x times negative x times negative x turns out to be negative x to the third. And then right here, negative x to the second, negative x times negative x is positive x squared. Now I've still got that minus 2. All right, so does this exactly equal what we started with? Is it exactly the same as the f of x that we started with? Well, no, it's not, because this one is negative and this one was positive. So that means it's not even. They're not exactly the same, therefore it's not even. All right, well, let's see if it's exactly the opposite. Are all the signs different from what I started with? Well, no, because these two are the same as these two. The orange one is opposite, but the ones in the pink circle are the same. So it's not exactly the opposite either. So this one is not odd. So this one does not turn out to be symmetric in any way. It is neither even nor odd. All right, let's look at some from some graphs. So if I look at this one, this is a graph. Those of you guys who take Algebra 3 or Pre-Cal, you'll run into this graph. And if you look, do you see that this point would rotate around here? This point would rotate around here. If I spun it 180 degrees, it would go right back on top of itself. So this function is odd. It doesn't matter. I don't need to see the equation. I can tell by looking at the picture that it's going to be odd because it spins right back on top of itself. All right, let's look at this one. So this one, if I look at it, I can see that on the y-axis right here, I have a line of symmetry. This part would reflect over on top of this part. This part would reflect over on top of that part. Most of you guys probably recognize this one. This one is absolute value of x, and I can say that absolute value of x, oops, forgot to click my pen. Absolute value of x is an even function because it's symmetric on the y-axis. Okay, now this one can be a little bit tricky because if you look, there is a line of symmetry right here. This one will flip over onto that one. This one will flip over onto that one. But is my line of symmetry the y-axis? No, the y-axis is over here. And you can see that if I try to flip this one across the y-axis, it would be really skinny on this side and much fatter on this side. It's not symmetric. They're not the same. So this one is neither. So even though it does have a line of symmetry, because that line of symmetry is not the y-axis, this is neither even nor odd. All right, let's look at some from the equations. All right, you guys remember from the equation, I'm going to test out f of negative x. So I'll put negative x in place of all of my x's. All right, well, here I have negative x to the fourth. So I'm going to write that one out so we can see what's happening. Anytime I have two negatives, they work together to make a positive. So I'm going to end up with x squared times x squared, which is x to the fourth. That plus 5 doesn't change, so I'm going to have that. And I forgot to bring down my 4. Now, if I look at this that I have right here, and I compare it with this that I started with, I can see that they are exactly the same. So when f of x and f of negative x are exactly the same, my function is even. All right, let's do the one below that. This time I've got g of x. I'll substitute negative x for all my x's. I'm always going to test with negative x. Okay, negative x to the third, negative x times negative x times negative x. I'm going to get negative x to the third. So negative times 2, that's going to give me negative 2x to the third. And then right here, positive 3 times negative x, that's going to give me negative 3x. So if I look at this and I compare it with this one, I can see that it's exactly the opposite. All of the signs are different than what they were before. So this is the opposite of g of x. And when g of negative x is equal to the opposite of g of x, then I can say that that function is odd. Okay, one thing I want you to notice with your exponents, do you notice that when your exponent is even, your variable turns out to be positive? And when your exponent is odd, your variable with the negative x turns out to be odd. So if you think, turns out to be negative. So if you think about this, anytime you have an even number of negatives, you're going to get a positive. Anytime you have an odd number of negatives, you're going to end up with something that is negative. So keep that in mind as you're simplifying these particular problems. Okay, last one. Let's test this one. So I'm going to put negative x in place of all of my x's. Negative x to the fifth, negative x to the second. All right, now let's simplify. Okay, so using what we just talked about last time, I can see that I have an odd right here and an even exponent right here. When I have an odd exponent, it's going to work out to be negative. Positive 7 times negative x to the fifth, that's going to give me negative 7x to the fifth. All right, now let's check this one. I have an even exponent, so that means this is going to be positive. Negative times positive is negative 2x squared. Then the plus 4 just comes down. Okay, so let's see what we have here. I noticed that this one is exactly the opposite of what we had here. But then I also noticed that these two are the same as what we had here. So they're not all opposites and they're not all the same. So therefore this one is neither. In order for it to be even, they all have to be the same. In order for it to be odd, they all have to be opposite. And this one is a combination of the same and opposite. So therefore it is neither.